What's up guys, this is Nick and Chris. We'll be explaining one of the many programs you can do involving VIs, LabVIEW, and myDAQ, mySTEM.
In this activity, we will be looking at a circuit and LabVIEW program setup which closely resembles a hand dryer commonly found in washrooms today. This VI makes use of a phototransistor and a light beam to turn the fan connected by a motor on and off.
The way this program works is when the light beam placed under the phototransistor is broken or covered, it turns on the fan. When the light beam is left alone, the motor will not run.
We will start off with the initial setup of the circuit. In this program, you will need a phototransistor, a motor with a propeller, a light bulb with a cover, and connector wires. This is the setup on the Fischer-Technic board that you will need to follow. In the circuit for the program, you will need to connect the setup to the mySTEM board. Before you start, make sure you have two wires connecting from 5 volts and ground to the negative and positive terminals. First, you'll need a set of wires to connect from the motor to output 2. Then, have a wire connect from enable 2 to DIO 1. Next, you want to have a wire connect from the light to output 1 and have a wire connect from enable 1 to 5 volts. Wire the phototransistor to the board with one going to positive and one wire going to one of the legs of the resistor. Incorrect wiring will destroy the phototransistor, which is a common error made by beginners, so it is crucial that you follow the diagram. On the resistor, you want to have one leg connected to negative, and for the other one, have a wire connected to DIO 0. Here is a view of the actual circuit for the program.
Alright, now we will be explaining the actual program that makes everything run. To begin the program, you want to place a while loop with a stop button on the block program. The program now needs to communicate with the motor. So now you want to add an output DAQ assist to the while loop and set it for a digital output on line 1. Next, you want to add a case structure and connect the stop button to the case. In the true case, place a false constant and have it connect to a build array that leads to the motor. Change the case to false and place the DAQ assist input block and set to acquire a digital input on line 0. This will act as a read sensor for the phototransistor. Then, you want to add a small case structure inside the original one and place a false constant in the false case and a true constant in the true. Connect the constant to the build array connected to the motor. Final steps are to add a wait block set to 3000 and connect the build array from the read sensor to the small true case.
Now, let's do a run of the program. You can watch everything that happens in the program by selecting the light bulb tool. The wait block in the program tells you how long the motor will take to turn on after the light beam is broken. When you cover the light beam, the motor will take around 3 seconds if it is set to 3000. It will also take 3 seconds to turn off after the light is uncovered. You could change the time by trying different values. Now, you can use the program as you please.
Thank you for watching our tutorial. If you follow these steps for the program and set up for the circuit, you will successfully build your own personal hand dryer using LabVIEW and myDAQ, mySTEM.